Hello students, in the last lecture we have studied about the galvanic cell, and in that galvanic cell we have studied also some types of electrodes. Various types of electrodes we have studied, and one of the important electrode, that is the reference electrode, in detail we have studied. So what is reference electrode and standard hydrogen electrode we have studied in detail. Electrode which potential is already fixed, whose potential is already known, such type of electrode is called as reference electrode, and standard hydrogen electrode in detail we have studied. Standard hydrogen electrode, that is the construction of standard hydrogen electrode, representation of standard hydrogen electrode, as well as we have also studied working of standard hydrogen electrode when it is coupled with the another one electrode in a galvanic cell. That points we have studied. Now today we have to study different types of galvanic cell which are used in our day-to-day life, like dry cell, lead storage battery or lead accumulator. In detail about it we have to study construction of dry cell, working of dry cell, and applications of dry cell. Now see, first of all, the primary voltaic cell. Primary galvanic cell means which cells? So that points now we have to study. That is nothing but primary cell means what? That is the cells. Primary cells means the voltaic cells. Voltaic cell in which electrical energy is generated within this cell, that is called as the primary galvanic or primary voltaic cell. Electrical energy is generated within this cell, that is not stored from any external agency, any external any external source. The electrical energy generated within this cell, that is called as the primary galvanic or primary voltaic cells. That is known as the primary voltaic cell. Dry cell is primary irreversible voltaic cell. Primary irreversible voltaic cell is nothing but the dry cell. Primary irreversible voltaic cell, that is the dry cell. Primary means electrical energy is generated within this cell only. It is not stored from any external source or the agency. And irreversible means its cell reactions cannot be reversed. Cell reactions cannot be reversed. Therefore, it is irreversible cell. If we apply external EMF to any extent, the cell reactions are not reversed in this cell, so they are called as the irreversible voltaic cell or the irreversible galvanic cell. After the name of inventor, that is Volta, invented this type of cell, and therefore these cells are also called as the voltaic cell, galvanic cell also. Now see, we have to study dry cell in detail. Dry cell, or it is Leclanche cell. Why it is called as Leclanche cell? It is what, that is the modified, it is modified Leclanche cell. Modified Leclanche cell means what? In Leclanche cell there is use of liquid electrolyte, but in dry cell paste of electrolytes are used. Paste of electrolytes are used, so it is dry cell. It is dry cell. Now we know that dry cell is a primary irreversible voltaic cell. Now we have to study construction of dry cell. After that we will study the working of dry cell. How does it works? That we have to study. So you see, this is nothing but dry cell. It consists of a outer, this metal or cylindrical vessel, that is zinc container. Outer cylindrical vessel, outer zinc container is there, and this outer zinc container itself act as, that is the anode. Itself it act as anode. This is outer zinc container. This outer zinc container or cylindrical vessel is act as itself anode. Then see here, inside this zinc container or this cylindrical zinc vessel, inside this zinc container or cylindrical zinc vessel, paste of ammonium chloride and zinc chloride is placed. यानी क्या, वो जिंक कंटेनर के अंदर पेस्ट ऑफ अमोनियम क्लोराइड और जिंक क्लोराइड की पेस्ट इंट्रोड्यूस करते हैं. इट इज प्लेस्ड. ओके, दैट इज द इलेक्ट्रोलाइट एट एनोड. देन सी एट द सेंटर ए स्टाउट ग्राफाइट रॉड इज प्लेस्ड. यानी कि इसमें कार्बन रॉड प्लेस करते हैं. एट द सेंटर ऑफ दिस वेसल a carbon rod is placed, and this carbon rod is act as graphite rod, that is act as cathode. It is act as cathode for the good electric contact. यानी क्या, हमें इलेक्ट्रिक कांटेक्ट अच्छे से मिले, इलेक्ट्रिक कांटेक्ट अच्छे से हो जाए, इसके लिए यहाँ एक ब्रास कैप फिट कर जाए, यानी क्या करते हैं उसके ऊपर. दैट इज ऑन द ग्राफाइट रॉड brass cap is fitted for good electric contact. Okay, for good electric contact a brass cap is fitted. Then see another one point, that is around this graphite rod or the cathode, paste of MnO2 and carbon, this mixture is placed around the carbon rod, around the cathode, paste of MnO2 and carbon, that is the electrolyte at cathode. And these two electrolytes are separated by a thin cotton partition. Okay, and then this is covered with a what, that is the wrapper, that is the paper spacer is used. In this way, this is construction of dry cell. It is the construction of dry cell. Now we have to study working of dry cell. Working of dry cell. Working of dry cell. Dry cell is a primary irreversible galvanic cell. Now during the working, what are the reactions take place at anode? Then we have to study reaction takes place at cathode. Overall cell reaction function, working of this cell, that is at anode, means this zinc container is anode. What happens, that zinc container itself undergoes the oxidation. So at anode, zinc solid undergoes oxidation. Zinc ions with the loss of 2 electron, that is oxidation reaction takes place at anode. यानी कि जिंक कंटेनर से जिंक एटम एक पेस्ट में जाते हैं, एज ए जिंक +2 आयन आर एडेड, दैट इज जिंक अंडरगोज ऑक्सीडेशन. ये देखो यहाँ Zinc gives zinc 2 plus ion with the loss of electron. This loss of electron here it is externally connected by external metallic wire. So these electrons now transferred towards this cathode. जिंक ने जो इलेक्ट्रॉन लूज किए हैं वो यहाँ एनोड से इस मेटल को हमने यहाँ कनेक्ट किया है वायर से, और वो वायर से बाहर एक्सटर्नल वायर से यहाँ इलेक्ट्रॉन आते हैं, यानी कि इलेक्ट्रॉन ट्रांसफर्ड फ्रॉम zinc anode to carbon cathode. So this is the oxidation reaction that is at anode. Now see reaction taking place at cathode. Reaction taking place at cathode. So at cathode which reaction takes place? That is nothing but ammonium ions. Ammonium ions accept 2 electron. It produces ammonia and hydrogen gas is liberated. So this is nothing but the hydrogen gas evolved. Hydrogen gas liberated, and it is not collected. It is not collected at cathode. Okay, this is the reduction reaction. Further, what happens? Hydrogen gas reacts with MnO2 paste of MnO2, and there is formation of Mn2O3. And what that is? The H2O. H2O. And a reaction takes place at what that is? The cathode is actually this one, ammonium ions plus what that is the twice of MnO2 accept 2 electrons. Here there is formation of Mn2O3 plus 2NH3 plus H2O. This is the reduction reaction taking place at cathode actually. Reduction reaction taking place at cathode. So here hydrogen gases act as depolarizer. That is nothing but it reduces to MnO2 to Mn2O3. हाइड्रोजन गैस ने Mn2O2 का Mn2O3 में क्या किया? रिडक्शन, बिकॉज here oxidation number of manganese plus 4 and here oxidation number of manganese is plus 3. So this oxidation number decreases, means MnO2 reduces into Mn2O3. Reduction reaction takes place. This is nothing but the working of what that is the dry cell. Working of dry cell. And net cell reaction, overall cell reaction, net cell reaction takes place in dry cell. नेट सेल रिएक्शन यानी क्या? ऑक्सीडेशन एट एनोड प्लस रिडक्शन एट कैथोड. सम ऑफ एनोडिक ऑक्सीडेशन एंड कैथोडिक रिडक्शन, that is nothing but the net cell reaction. And here you see you have to combine these two reactions, that is the zinc solid plus here you take to balance the equation 2 twice of NH4 plus ions, then what that is the MnO2 twice of MnO2 twice of MnO2, loss and gain of 2 electron gives zinc plus 2 ions in aqueous state plus twice of ammonia plus Mn2O3 plus H2O. This is nothing but the net cell or overall cell reaction taking place in dry cell. Overall cell reaction taking place in dry cell. And one point here you have to remember that in this cell reaction there is formation of ammonia and already zinc ions are formed at anode. So what happens? That is the zinc ions and ammonia combines to gives complex. Hence they are not available for reverse reaction, and therefore their reaction cannot take place reversibly. Reverse reactions cannot be takes place in this reaction, or it is an irreversible reaction. If asked in this way, that is what is the EMF of dry cell, it is near about 1.5 volt to 1.6 volt. 1.5 volt is the EMF of dry cell So here zinc ions combines with ammonia and there is formation of this complex ZnNH3 by 4. Here 2 plus ion. This complex is obtained and this complex is strong, stable. Therefore, they are not available for the reverse reaction and hence the reaction is not reversed. It is a irreversible reaction. This is the working function construction of dry cell. One more point here you have to remember uses. Dry cells are used in transistor, torches, wall watches. They use of the dry cell. Now we have to study another type of galvanic cell, and that another type of galvanic cell we have to study now. Here see. Okay, see the next type of galvanic cell that we have to study. It is secondary galvanic cell. Primary voltaic cell just we have studied. Now we have to study secondary voltaic cell. What is secondary voltaic cell? Example of it, and in detail we have to study that one. Secondary voltaic cell in detail we have to study. It is the dry cell, lead accumulator or lead storage battery. Lead accumulator or lead storage battery. So see, secondary voltaic cell. Secondary voltaic cell. Secondary voltaic cell means a galvanic cell. It is a galvanic cell in which electrical energy is first of all stored from external sources, and then use up that cells are called as secondary cells. They are known as the secondary galvanic cells और सेकेंडरी वोल्टाइक सेल। इन दिस सेल में, इस सेल में क्या होता है कि हम पहले इलेक्ट्रिसिटी आउटर सोर्स से स्टोर करते हैं और उसके बाद वो यूज करते हैं, यानी कि इलेक्ट्रिकल एनर्जी इज नॉट जनरेटेड विद इन दिस सेल। यानी क्या, इलेक्ट्रिकल एनर्जी इज नॉट जनरेटेड विद इन दिस सेल, दैट इज फर्स्ट part stored from the external sources and then it is used up. So that cell is called as the secondary cells, or it is a secondary voltaic cell. Secondary voltaic cell in detail we have to study. It is lead storage battery, lead storage accumulator or lead accumulator or lead storage battery. In detail we have to study. So lead storage battery is also called as lead accumulator. Lead accumulator. So lead accumulator, what that is the lead accumulator is a secondary, it is a secondary reversible voltaic cell. It is a secondary reversible voltaic cell. You know meaning of secondary, that is cell in which the electrical energy is generated from the external source and then used up. And what is meant by reversible? When external EMF applied to this cell is greater than this cell, then that cell is called as the, this cell reactions are reversed. अगर एक्सटर्नल EMF हमने इस सेल को इस सेल से ज्यादा अप्लाई किया तो उस सेल में जो रिएक्शंस है वो एग्जैक्टली रिवर्स होते हैं. सो देयरफॉर इट इज कॉल्ड एज द रिवर्सिबल सेल. यानी क्या, दिस सेल कैन बी चार्ज्ड एंड दिस सेल कैन बी डिस्चार्ज्ड. So discharging and charging both process take place during this working of cell or this cell. So here see construction of lead accumulator, construction of lead storage battery or lead accumulator. So how this cell is constructed, that we have to study now. Here see the diagram of lead storage battery, or what that is the lead accumulator. Diagram of what that is the lead storage battery or lead accumulator. So this is nothing but the lead storage battery, lead accumulator. It is the cell which consists of a plastic or glass vessel. You see the construction of this cell. It consists of a plastic or glass vessel. Now in this plastic or glass vessel, 38% H2SO4 is placed first form. 38% sulfuric acid is placed in it. That 38% sulfuric acid is used as electrolyte. इसमें इलेक्ट्रोलाइट का रोल करता है, इसमें इलेक्ट्रोलाइट यूज होता है. That is 38% H2SO4 whose specific gravity is 1.21. Whose specific gravity is 1.21. Okay. Then see here what are the anode and what are the cathode, which are the anode and which are the cathode. Anodes are made up of lead plates, Pb plates. Anodes are made up of pure Pb plate. You see here, that is Pb plate packed with spongy lead or only it is lead. So this is nothing but anode, it is also anode. And cathodes are Pb plates impregnated with PbO2. Pb plate packed with PbO2, that is nothing but the cathode, and these plates are alternately placed in this 38% H2SO4. So you see once again, this cell consists of a plastic or glass acid proof vessel in which 38% H2SO4, that is used as electrolyte, is placed, whose specific gravity is 1.21. Then second one thing here you have to remember, alternate Pb plates and Pb plates impregnated with PbO2 are placed. Pb plate packed with spongy Pb is act as anode, and Pb plates impregnated with or packed with PbO2, they are act as cathode, they are alternately placed. This is the construction of what that is the lead accumulator, lead storage battery. Now see, we have to study representation of cell. Representation of cell. Cell represented in this way. So here see, what that is the Pb impregnated with PbO2 solid. It is in contact with what that is the PbSO4, because when it is placed in H2SO4, it readily forms PbSO4. Then here also direct contact PbSO4, here solid, and here what that is the Pb solid. So it is anode negatively charged, and this is what that is the cathode positively charged. 1 minute please. That is H2SO4 here. H2SO4 aqueous solution 38%. Here PbSO4 solid. Here what that is the PbO solid and Pb solid positively charged electrode. Here directly these lead plates impregnated with PbO2 are placed in H2SO4, so it forms PbSO4. Here lead plates are directly inserted in H2SO4, it forms PbSO4, and this is nothing but the representation of lead storage battery or representation of lead accumulator. Now we have to study working of lead storage battery, working of this cell, working of cell. How does it work? As we know that cell is reversible, therefore two types of working is there. Reactions take place at this in this cell during the discharging, and then we will study during the charging. So here see, discharging, first of all see, that is the discharging. Now discharging, when discharging is there, the cell is act as voltaic cell. When the discharging takes place, means when we use that cell, then discharging is take place, and during the discharging, reaction takes place at anode, that is oxidation. So reaction takes place at anode. Pb solid react with sulfate ions, there is formation of PbSO4 solid with the loss of 2 electron, oxidation. Now at cathode, reaction taking place at cathode during discharging, PbO2 solid react with sulfuric acid, 4H plus ions plus what, that is the sulfate ions, by gain of 2 electron. Here also there is formation of PbSO4 solid with the formation of twice of H2O. This is the reduction. So what happens in this cell? From this lead plate, which are act as anode, Pb goes into the solution of H2SO4 with the loss of 2 electron. Each lead ion loses 2 electron at this lead plate, and that electrons will becomes at this cathode through external circuit. And that Pb plus 2 ion produces in the solution, they combines with the sulfate ion of sulfuric acid, and it will produce as the PbSO4 lead cell. Now these electrons come at the cathode from anode, they are accepted by this PbO2. Okay, it reacts with sulfuric acid by gain of electron, and it will produce as the PbSO4. So oxidation takes place at anode and reduction takes place at cathode. From this we can write net cell reaction. Net cell reaction or overall cell reaction means anodic oxidation plus cathodic reduction, or oxidation at anode plus reduction at cathode, that is the overall cell reaction. So here it is Pb solid, this one, plus what, that is the PbO2 solid. Then here 2H plus 4H plus ion and 2 sulfate ion, 2 moles of H2SO4. Twice of H2SO4 aqueous, and here there is formation of twice of PbSO4 solid, here PbSO4 plus twice of H2O, and this is a redox reaction. Approximately EM of this cell is 2 volt. EMF of the lead storage battery of one cell 2 volt. Here how many cells? 2 cells. One pair, second pair. So that is the 4 volt. So if you multiple this cell, the voltage also get multiple. Voltage also get what, that is the multiple. This is nothing but the working of this cell during the discharging. So during the discharging, cell is act as voltaic cell. That is the chemical energy is converted into electrical energy, and here electrical energy is produced. Oxidation takes place at anode, reduction takes place at cathode. Now here see why during the discharging specific gravity of H2SO4 falls, because water is formed there, so specific gravity falls. Second one point is that during the discharging of this cell, sulfuric acid is consumed. Here see, sulfuric acid is consumed and lead sulfate is formed. PbSO4 is formed. Now we have to study second one point here, that is the charging of cell. Charging of cell. One point here you have to remember, when external EMF applied to this cell is greater than the 2 volt, then cell reactions are exactly reversed, and this cell behaves a electrolytic cell. It behaves electrolytic cell when the charging of cell is take place. Now that reactions we have to study during the charging of cell. Reaction takes place at anode. Here anode means positively charged electrode because it is electrolytic cell now. So reverse reaction you have to takes place at what that is the anode means gain of electron. Here see PbSO4 accept 2 electron. Pb is deposited at Pb plate and here SO4 2 minus. Here reduction reaction is take place. तिकडच्या एनोड वरची रिएक्शन जी आहे ती इकडे कॅथोड वर होणार आहे. सॉरी हा, इट इज कॅथोड बिकॉज रिडक्शन रिएक्शन and cathode is negatively charged. Charge जो आहे तो same right but it is reverse denotation. Now reaction taking place at anode that is oxidation. Positively charged electrode वरची reaction opposite ल्यायची, that is PbSO4 plus twice of H2O. Here gives PbO2 plus 4H plus ion plus sulfate ion with the loss of 2 electron, oxidation. This is charging. यानी कि जब सेल की चार्जिंग होती है तो रिएक्शंस आर एक्झॅक्टली अपोजिट. निगेटिव्ह इलेक्ट्रोड वरची रिएक्शन तिकडची काय करायची, एक्झॅक्टली अपोजिट ल्यायची. इकडे निगेटिव्ह कॅथोड आहे, तिकडे निगेटिव्ह एनोड आहे. इकडे पॉझिटिव्ह इलेक्ट्रोड वरची तिकडची रिएक्शन एक्झॅक्टली अपोजिट ल्यायची. तिकडे पॉझिटिव्ह इलेक्ट्रोड कॅथोड, इथे एनोड. राइट. सो ऑक्सिडेशन टेक्स प्लेस and net cell reaction takes place during the charging of this cell is exactly opposite to that of the discharging. So here take twice of PbSO4 solid plus twice of H2O. Pb deposited at Pb plate, PbO2 deposited at Pb plates impregnated with PbO2, and here there is formation of sulfuric acid. So during the charging, lead sulfate is consumed and sulfuric acid is produced. Lead sulfate is consumed and sulfuric acid is produced, and therefore again cell get charged. And this is nothing but the construction, representation, working of lead storage battery during the discharging, working during the charging. When discharging takes place, it behaves voltaic cell. When the charging takes place, it behaves electrolytic cell. And this is nothing but the working of this cell. Some maintenance you have to remember. Cell should be kept in ventilation. When cell is not work for a long time, then total acid is removed from it. The terminal get cleaned time to time for good electric contact. And there should be addition of acid in the battery to maintain the level, or that electrode should get totally dipped in the acid. Uses of this cell, these cells are used in self-start automobile. जो भी self start अपने बाइक्स व्हीकल्स होते हैं उसमें ये सेल यूज होती है. That it is used in self-start automobile. It is used in what that is the laboratory for a direct current supply. It is used in telephone and telegraphic offices also. And nowadays it is also used in our house with inverter as a direct current supply. So that is nothing but the uses of lead storage battery or lead accumulator. While starting the automobile, this cell behaves voltaic cell, and once the automobile start its charging takes place, it will behave the electrolytic cell. So this is about the different type of cells which are used in our daily life. After this one type of cell we have to study, it is fuel cell, and one type of fuel cell we will study in detail later.